And now let's talk about the structure of the vein. As we know that veins don't carry blood at high pressure, as most of the blood pressure has been lost across capillaries. As we know, the blood passes at high pressure from arteries, then it goes through smaller arterioles, then from arterioles to capillaries now. So arteries branched into arterioles, then from arterioles into capillaries at the level of the cell. Then the blood back to the veins from capillaries through venules. Then venules get wider and wider, becoming veins. So here the most of the blood pressure has been lost across capillaries. So the blood which is going back is low at low blood pressure. That's why no need for the vein to tolerate or to withstand blood pressure. In this case, the vein should be wide in order not to resist the blood that is going against gravity back to the heart. Suppose that there is blood actually coming back to the heart from your legs. Now the blood is being pulled by gravity down, and the blood needs to go up. In this case, the hole or the cavity of the vein is wide in order not to resist the blood, because if it was narrow, then the blood cannot pass freely upward across the organs back to the heart. That's why a lumen of the vein is wide, as you see here. Here is a vein and here is an artery, and no need for the vein to have thick wall and thick muscle, because it doesn't need to squeeze or to recoil blood. But it has valve. It has valve as it is shown in page 115, and in the picture in the guideline that there is a valve. This valve, it prevents backflow of blood. So once the blood going up against gravity, it doesn't go back. The valve closes in order to keep it upward in one direction. At the same time, most of the veins are located near muscles. So once you move, these muscles contract, squeezing on the blood vessels, or squeezing on the veins, pushing the blood upward. So these are the main adaptations of veins and arteries. So veins, narrow, thin wall, thin muscle, wide lumen in order to reduce resistance towards blood. Thin lumen and thin muscle in order no need to tolerate high blood pressure, because the blood is passing at low pressure upward back to the heart. Here is a picture actually that shows the three types: artery, vein, and now capillary, such as the one that you have it in your book 114. Here is cross sections through each of them. As you see, capillary, in order to make efficient diffusion and pass materials directly to the tissues or to the cells, so it should be very thin, so the particles or the materials can pass across short distance. So it is only one cell thick. So the capillary, only the wall is made up of one cell thick. It is very tiny, very thin, no muscle. The wall is very thin, one cell thick for efficient diffusion. Okay. Here are the main blood vessels. You have to know their names. This is a diagram that shows the main blood vessels actually going to the main organs. Now look what is being pumped: oxygenated blood out of the left side, the one as you have it in page 115. You have figure 9.17, page 115, and the names of these arteries and veins are mentioned in the guideline. So first of all, once the blood is pumped from aorta, it goes to many organs. Now the artery which is going to the liver, it is called hepatic artery. Anything which is hepatic relates to liver. The artery which is going to liver, hepatic. What is going back from liver to the heart? It is also called hepatic, but hepatic vein. Because it is going, vein means going back to the heart. Now, what is going to the gut or intestine, the intestine becomes under liver directly. What comes under liver in the diagram is the intestine or gut, your digestive system. What goes to your digestive system